Hey guys, and welcome to this school station. Today's video I'm going to be talking about Group 1 of the periodic table, Alkali Metals. This is from the AQA GCSE Chemistry 91 paper from the unit Atoms, Bonding and Moles. Today's video I'm going to be talking about alkali metals and what they are, and also its reactivity, its density, and also its reaction with water. So let's just get right into the video. So first of all, we actually have to look at the group itself from the periodic table. So alkali metals have 6 elements: lithium, sodium, potassium, rubidium, cesium, and francium. So in the periodic table, these will already be mentioned, so you probably not have to memorize these if you have a periodic table during the exam. But as you guys can see, these are the 6 elements that alkali metals are. Now we're going to be going on and talking about its reactivity. So alkali metals are very reactive and are stored in oil to stop the reaction with oxygen in the air. So alkali metals even react with oxygen in the air, which shows that they're very reactive. And to stop the reaction with oxygen in the air, they actually are stored in oil. So we generally have to know that alkali metals, which is group 1 of the periodic table, are very reactive. Reactivity increases going down the group. So what this means is that over here, as you guys can see, we have lithium, which is the first element of the alkali metals, and francium, which is the last element of the alkali metals. And reactivity increases going down the group, which means that it gets more and more reactive as you go down. So cesium will be more reactive than sodium, and sodium will be more reactive than lithium. So the reactivity increases going down the group. So you'll have to memorize this and you'll have to know this for the exam, because this is really important for you to know. All the atoms of alkali metals have 1 electron in the outermost shell, highest energy level. This gives them similar properties and very reactive, as they need to lose 1 electron to get the stable electronic structure of a noble gas. So basically, alkali metals have 1 electron in the outermost shell, because if you guys have watched my video about the periodic table, you guys will know that there are similarities between groups and periods, or the similarities between elements in a group is that they have the same electron in the outermost shell. So all of these elements have all 1 electron in the outermost shell because it is in group 1. So since they have 1 electron in the outermost shell, they basically can just lose this one electron, and they will get the stable electronic structure of a noble gas. So we'll be looking at this more later on, but if you either have to give away 1 electron or you have to take electrons, and in the case of alkali metals, you just basically give 1 electron away and they will actually get a stable electronic structure of a noble gas. And last of all, they also react with non-metals, losing the single outer electron. So when they react with non-metals, they again lose a single outer electron and they become very reactive. So now they've talked about reactivity and we've understood that alkali metals are very reactive and the reactivity increases going down the group. Now we have to think about the density of alkali metals. So all the alkali metals have a very low density compared with other metals. In fact, the densities of lithium, sodium and potassium are all less than 1 grams per centimeters cubed. So we should know that the water's density is 1 grams per centimeters cubed. And since the densities of lithium, sodium, potassium are all less than the density of water, this means that they actually float on water. The other ones probably don't float on water, but they still have a very low density. So that's something you'll have to know for the exam, that water's density, it was 1 grams per centimeters cubed, and anything that is less than 1 grams per centimeters cubed will float on water, and anything more than 1 grams per centimeters cubed will sink on water or will drown. So therefore, the densities of lithium, sodium, potassium are very low, which is why they can float on water. Now we're also going to be talking about the melting and boiling points of alkali metals. The group 1 metals melt and boil at relatively lower temperatures for metals. So usually metals, they might actually melt and boil at more high temperatures, but the group 1 metals melt and boil at relatively low temperatures for metals. So therefore, like a typical metal may melt and boil at a high temperature, but the group 1 metals melt and boil at relatively low temperatures. And the second point that I want to make is that going down the group, the melting points and boiling points get lower and lower, they decrease. So again, this is something you'll have to memorize. Just like reactivity increases going down the group, you also have to remember that going down the group, the melting points and the boiling points get lower and lower. So again, as you go down, the melting and boiling points get lower and lower. So lithium has the highest melting and boiling point, and francium has the lowest melting and boiling point. So that is again something you will have to remember for the exam. Next, we're also going to be talking about the reaction with water. So as I said, there are 6 elements in group 1, and you actually have to understand that since they're very reactive, they're also going to have a very big reaction with water. So as I said, reactivity increases as you go down the group. So first of all, when we start off with lithium, it reacts very slowly with water. It kind of fizzes, but it's not really very serious, and it forms a colorless solution. And then when you go down, it just gets a bit worse and worse until you get to francium, when it is too dangerous and harmful to even try. So you can pause this video and just kind of look at these notes and try to understand that as you go down the group, its reactivity increases, which is why when you actually put any of these elements in water, it's just going to get worse and worse as you go down the group, because lithium just reacts slowly with water, but when you get to francium, it's too dangerous and harmful to even try, because the reaction happens in a few seconds. Because for example, in cesium, if we actually just put cesium in water, it crackles and creates a really big explosion. It only takes a few seconds for it to become a huge explosion, which is why even the scientist who does the reaction with water and cesium has to quickly run away or go to a safe distance to make sure that they don't get harmed. So therefore, reactivity increases going down the group, and this is why the reaction with water gets bigger and bigger every single time you go down the group. And last of all, we also have to think about the generalized equation between a metal and water. So as I said, this is basically the reaction between the metal and the water. So the equation for this is metal plus water makes metal hydroxide plus hydrogen. So basically, for example, if I use this equation for lithium, we will basically do lithium plus water makes lithium hydroxide plus hydrogen, because when you're doing the reaction, you will see that a lot of hydrogen actually gets released. So that would be lithium hydroxide plus hydrogen. So you can do this for every single one of the metals. You just substitute the metal with the actual name. So if I was doing rubidium, I would again just put rubidium. So rubidium plus water makes rubidium hydroxide plus hydrogen. So it's a really simple equation to just memorize and use in exam. So that's basically everything we actually found out about alkali metals, its reactivity, its densities. Just as an overview of what we have learned today, we learned what alkali metals are. We've also learned the properties of alkali metals, so how reactive they are, what's their densities, what is the reaction with water for them, and we've also learned its melting and boiling points. And we've also learned the reaction between alkali metal and water, so as it goes down the group, the reaction just becomes more bigger and more explosive. And fourth of all, we also learned that the generalized equation between a metal and water is obviously metal plus water makes metal hydroxide plus hydrogen. So I hope you guys have enjoyed this video, and I hope this helps you. Definitely give this video a thumbs up and subscribe to the school station for more free science and maths lessons. Bye guys!